Hello everyone. How are you all? I hope you all are doing very good. See children, physics is never a difficult subject for a student who is interested, provided he or she has a clear and strong physics teacher. So here I am, Mr. Dharanidhar, your favorite physics teacher in your favorite YouTube channel, Bhautics. So today I brought you one more question that was asked in the previous year board examination in year 2014, question paper set number 31/4/1 for 5 marks. This question has two parts. This is first part and second part is also there. We will solve soon. Question goes like this. They asked us to define principal axis. Principal axis can be defined as a straight line passing through 2f1, f1, optical center, f2 and 2f2 of any length is called as principal axis. And now they also ask to draw a ray diagram when light ray passes parallel to principal axis of a concave lens. Remember, when we are drawing any lens, we should take a straight line that can be exactly divisible by 4. I used to take 12. We can take 8 also. And mark the points at 2, 4, 6 and 8. If we are drawing ray diagram for image formation, then if we take 12 centimeters, that will be very good. But here we are drawing only for the ray diagram representation. So we can mark 8 centimeters and divide that whole into 4 parts. Name the points as optical center f1, 2f1, f2 and 2f2. Now you take the compass and take the radius, which lens is concave lens, right? So take the radius of curvature just lesser than the half of the optical lens is somewhere here. If you take and draw an arc like this, okay, and take the center as another 2f1 and mark another arc. This will complete the lens construction. Draw a straight line here and a straight line here also, and this line which passes through optical center, it should be drawn definitely. So now erase the extra part, so it will give a good look to the diagram. So now our intention is to, when incident light ray passes parallel to principal axis of concave lens. So this is principal axis. Take one light ray parallel to principal axis until where? Until it touches this line. Okay. So now how the refracted light ray will be there? Refracted light ray will appear that it is diverging from the focus. See, this point and this point should be focus and this point should be in line. So from focus you take a dotted line, and from this line you take a thick line. This one will be the refracted light ray. So this completes the part A, and there is part B also for the same question. Question here is, the focal length of concave lens is 20 centimeters. Focal length of concave lens is from optical center to focus. It is 20 centimeters. At what distance a 5 centimeter tall object should be placed so that the image is formed at the 15 centimeters. Image is formed at 15 centimeters. At what distance we have to place the object? This question is asked differently. See, they are asking to find out the object distance, not the image distance. Generally, they will ask us to find the image distance, and they ask us to find the image height and magnification. Here they ask us to find the object distance. Okay, a bit differently they asked, not difficultly, differently. So what is given data? Let us write down. Which lens it is? Concave lens. Concave lens. So focal length will be negative. So they also give focal length. Focal length f is equal to minus 20 centimeters. Object distance is what we have to find out. Object distance we have to find out. They have given the image distance. Image distance V is equal to minus 15 centimeters. So we have to find out the object distance, and also we have to find the magnification, right? So let us find out the object distance by using the lens formula. What is lens formula? Lens formula will be 1 by f will be is equal to 1 by V minus 1 by U. Focal length how much they gave? Minus 20. We remember that while substituting the values into lens formula, we should give with polarity. While coming out, a unknown quantity will come with the polarity. We know that the object distance will be always negative, but we should not give polarity to object distance. Now V is also minus 15 minus 1 by U. So I want to find 1 by U only. So I will send this minus 1 by 15 that side. It becomes plus 1 by 15 minus 1 by 20 will be is equal to minus 1 by U. So I want to find U only. This minus I will send that side. If I send minus to the opposite side, which number has minus, it becomes positive. Which number has positive, it becomes negative. So this step I'll write here. Minus 1 by 15 plus 1 by 20 will be equal to 1 by U. So 15 and 20 LCM will be how much? 15 2 is 30, 300. It will be 60. 15 4 is 23. So 15 4 is 60, 23 is 60 is equal to 1 by U. Minus 4 plus 3, it is minus 1 divided by 60 is equal to 1 by U. So we can write after cross multiplication, U will be is equal to minus 60 centimeter. So we got U as minus 60 centimeters. Now you draw a box for it so that it will give a good look to the examiner. They did not stop the question there. They also asked us to find the magnification. What is the formula for magnification in lens? Formula for magnification is M will be is equal to V divided by U. So magnification M is equal to V, how much it is? V is minus 15 centimeter. U is minus 60 centimeter. So minus minus cancel. 15 ones are 15 fours are. So magnification M is equal to 1 divided by 4. So we got magnification also and we got the object distance also. Right. So we should write the conclusion statement for the question. What is the conclusion statement? See, image is formed at 15 centimeters. They ask us to find out the object distance. So object should be placed at 60 centimeters and the magnification is plus 1 by 4. This is the concluding statement of the question. So this is how you need to answer a question asked in the board examination. Thank you so much. If you are interested to join our online classes where we teach CBSE Class 10 Physics, you can contact us. Thank you.